The slope of a line is another word for its steepness. This ramp, for example, is really steep. In math, slope is just a measure of how something changes vertically, or up and down, compared to how much it changes horizontally, or left and right. Well, to find a line's slope, you've got to look at two or more of its points. The line of this ramp can be thought of as a series of points that are connected. Right, the best way to visualize this is with a coordinate plane, a two-dimensional representation of space. For details on that, check our coordinate plane movie. Every point on a coordinate plane has a numbered location, kind of like coordinates on a map. A point's location along the y-axis is its y-coordinate, and its location along the x-axis is its x-coordinate. To find the slope of a line, you need to find out how much its coordinates change as the line goes along. Alright, let's take a look at 2 points along this here skate ramp. One point has the x-coordinate 5 and the y-coordinate 6, while the other has an x-coordinate of 0 and a y-coordinate of 1. To figure out the slope, we want to find out how the positions change exactly. The slope, or m, is equal to the amount of change in the y-coordinates divided by the amount of change in the x-coordinates. Right. Some people call that rise over run. It helps you remember that it's a vertical change over a horizontal change. Let's try it for the ramp. Our two y values are 6 and 1, and our two x values are 5 and 0. So the slope for this ramp is equal to the change in y, that's 6 minus 1, divided by the change in x, or 5 minus 0. The slope is 5 over 5, or 1. In other words, for every 1 meter this ramp goes up or down, it goes across 1 meter. You can find the slope of any straight line the same way as long as you know the coordinates of any 2 points. Maybe you should go first. Oh, almost forgot the intercepts. An intercept is a point where a line hits or intercepts the x or y axis. For our ramp line, the x-intercept is minus 1, 0, and the y-intercept is 0, 1. Well, the y value of the x-intercept is always 0, and the x value of the y-intercept is always 0. What? That's just what happens.
So now that we've heard from Tim and Moby, we're going to take a look at a couple of examples from your guided notes. So rate of change is basically just slope. It's what's that amount that's changing in our y over the amount changing in our x. So if we look at a real-world example, college admissions in 2004 was 56,878, and then in 2006 it was 60,291. So if we want to find the rate of change, we would find the change in our y, so the amount of students per year, so per year meaning divided by the years, so the change in our years. So we set it up with subtraction there, and if we go ahead and subtract, we would get an answer of 3,413 over 2. And then we could go ahead and divide that to see that we have 1,706.5 per year. And that would be an increase of admissions. Next example, even though you don't have the table in your notes, we can still refer to the table here. It's a business example referring to the graph. So it shows the data on the fastest growing restaurant chain in the U.S. during the time period listed here below, 2001 to 2006. So we have the number of stores increasing, so from here to here, looks like it would be about an increase of 30 from, well, maybe that's 6 to 34. So 34 minus 6, because we are a little bit above. And then from year 2001 to 2006 is a difference, or I guess it would be 1,000, if we're going up, looks like we're starting there. Just say it's an increase of 5 there. So if we went ahead and subtracted, we would get about 5.6 as our average rate of increase. And since this is in thousands, over here we look at our legend, it would be about 5,600 students increasing. And then meet Mr. Slope, and Mr. Slope's face is a little bit different than what it should be. It should actually look like that. We'll just make him have a little goatee there, even though there's not supposed to be anything. There he is. So we should have a plus here. So this is the slope going up from left to right is a positive slope. Going down from left to right is a negative slope. And a vertical line is an U, undefined. And then our slope of 0 as our mouth there with our little zeros on the side. So our slope formula we already talked about and you've seen before, should be review. So what we're going to do is go ahead and plug this in. So here's our x1, here's our y1, here's our x2, and here's our y2. And then we're just going to go ahead and plug it into our formula and simplify. So we have -2 minus 4 over 1 minus -1. So make sure that double negative changes to a positive, and we would get -6 over 2, and we would wind up with a -3 as our slope. For finding slope from our graphs here, rise over run, as Tim and Moby were referring to. So how much are we rising from this point? We're rising 1, and we're running 2. So if we have a rise of 1 and a run of 2, it would be a slope of 1/2 for A. Notice we're going from left to right, we're going up, like Mr. Slope's eyebrow on the left there, so it's a positive slope. Make sure that's a positive 1/2. And then over here, we're going down from left to right, so our answer, or our slope should be negative. And then let's pick 2 points that are on an intercept there. From there to there, we're going down 1, right 2. So down 1, right 2, so it's a -1/2 for our B.